Welcome to my presentation. In this presentation, we shall see examples of derivative of a function using limits. Let us say we want to find the derivative of this function. F of x is equal to 3x squared minus 2x. Okay, so the way we want to solve it is as follows. Step number 1. We want to write the formula down the way we know it. The formula for the slope or the derivative is going to be equal to the limit as h approaches 0, f of x plus h minus f of x, the whole thing divided by h, like that. Now in step number 2, we're going to substitute the function. So the limit as h approaches 0, we're going to substitute 3 times x plus h the whole squared minus 2 times x plus h, like that. And this is all one part of the first part of that formula. The second part of the formula is 3x squared minus 2x, like that. This whole thing divided by h. And then we're going to put all of that in another big bracket like that. So as step number 3, we're going to simplify the math. Step number 3, we're going to simplify the math. Limit as h approaches 0, we're going to expand this numerator part. 3 times x plus h, the whole thing raised to the power of 2, we can expand it out as x squared plus 2 times xh plus h squared, close parenthesis, minus, we're going to distribute the negative 2 to every one of the terms inside the parenthesis. 2 times x is 2x, 2 times h is negative 2h, like that. And then here again, we're going to distribute the negative sign to every one of the terms inside the brackets. Negative times 3x squared is negative 3x squared, like that. And then negative times negative 2x is a positive 2x, and this whole thing divided by h, like that. We can simplify this some more. In this next step, we're going to distribute the 3 in the numerator part. So 3 times x squared is 3x squared. 3 times 2xh is going to be equal to 6xh. 3 times h squared is going to be equal to 3h squared. And then the rest of the equation we can write it as is negative 2x minus 2h minus 3x to the power of 2 plus 2x, this whole thing divided by h. Now we see some similar terms in the numerator part. We have a positive 3x squared and a negative 3x squared, that cancels out. We have a negative 2x and a positive 2x, we can cancel that out. And therefore, we are now left with this part of the equation. We can now write this one out as limit as h approaches 0. We have 6x squared plus 3h squared minus 2h. So we can pull out h as common in the numerator. So we are left with 6x plus 3h minus 2, the whole thing divided by h. The reason I pulled out h as common is because I have an h in the denominator, so I can cancel those out. So when I simplify this some more, it is going to come out as limit as h approaches 0, we are left with 6x plus 3h minus 2, like that. Now we can apply this limit to every one of these elements or these terms inside the brackets. So limit of 6x as h approaches 0 plus limit of 3h as h approaches 0 minus the limit of this constant term 2 as h approaches 0. So when we simplify this, limit of this function 6x as h approaches 0, it is going to remain as 6x, and then the limit of 3h as h approaches 0 is going to go to 0, and then the limit of a constant number as h approaches 0 is going to remain as a constant number 2. So therefore we are left with 6x minus 2, and this is our answer. This is the derivative of the function. So what did we do here? To sum it up, we can write this one out as, if the given function is 3x squared minus 2x, like that, then we can state that the first derivative of this function is equal to 6x minus 2, and that is what we have proven that. This is our derivative of the given function. In my next presentation, we shall see more examples on how to find the derivative of a function using limits.